Good morning.
Good morning, sir.
Good morning, sir.
Good
Good morning.
morning, sir.
Good morning. Just check screen is visible and my voice is audible.
Yes, sir.
Yes, sir.
Okay, very good morning. Meanwhile, those students will join. Let us see what we have seen yesterday, so that it will be a mere revision. What we have seen yesterday. So yesterday's lecture was started with the concept of or the statement of principle or law of transmissibility of force. So here we have discussed what is that statement, principle, or we can say law of transmissibility of force. So few questions I have asked. So what was that? So as far as force is concerned, so what we are going to transfer, where we are going to transfer, and what is not going to change. Okay. So statement was that something like the state of rest or uniform motion of rigid body is unaltered or unchanged if the point of application of the force is transmitted to
Hello, sir.
any other.
हा सर माझ्या ह्याला रिनेमचा ऑप्शन येत नाही.
Just wait. Check now.
ओके सर, ओके.
So principle of law of transmissibility of force. So that statement we have seen. So whenever we are going to consider any force, so what we are going to shift, so which thing we are going to shift, where we are going to shift, and what will not change. So which are the answer of these three questions? So if at all there is any force, so what we can shift?
Point of application.
Very good. Point of application. If at all we are going to shift point of application of force, where we are going to shift?
On the line of action of
Other
force.
point.
Very good. On the line of action of force. And what will not change?
Effect.
Of rigid body.
What will not change?
State of rigid body.
State of rigid body, or we can say effect due to that force will not change. Means whatever it will be with the effect of that force on the body, it will not change, irrespective of whenever it may be we are going to show that force, whenever it may be we are going to show that force on line of action, irrespective of, it will not change. Okay, so that statement we have seen. So what is statement? The state of rest, or uniform motion of a rigid body is unaltered if the point of application is not going to change. So this we have seen yesterday. This one is most important whenever we are going to calculate movement, etc. So in case of movement, we have to multiple force and perpendicular distance. In that case, this concept is very important. I will tell at that time also. So how it is important. So that we have seen. In short, if at all we are going to shift point of application along the line of action of force, its effect on the body will not change. We can show anywhere that force on the line of action. So that is the meaning of that. Okay. So after that, a few examples we have seen actually. So how it is, means particular body, again there is a line of action and how that force is shown on that. So it is there. Again examples yesterday we have seen. I have given name to one of the point, then here also I have given one of the point, and whatever that line is shown, line of action, we can show that force at any point. That was our conclusion of that principle or law of transmissibility of force. Okay, then we have discussed resolution and resultant. What is the resolution? One to many or many to one?
One to
many.
Resolution?
One to many.
One to many. Resolution means one to many. Once we are going to convert one force into its component, or one force is going to convert into its many component. Many means only two. We are going to convert that force into two components, that we will see. And what is the resultant? Many to one or one to many?
Many to one.
Resultant means many to one. A resultant is a single force which gives the same effect as that of system of force. Means whatever it may be, the number of forces are there in a system, so it should convert that number of forces into one. That is resultant. Only care we have to take away is what? It should not have a different effect. Effect should be same finally. That we have seen. Resolution, resultant. These two terms are also important. Resolution and resultant. Further, a few examples are there actually, so that we will see. Actually, once a little syllabus will complete, you will come to know that how it is. It can be done by simple algebraic, means forces are collinear. So simple algebraic addition you can do. Like this, it is told me it is not applicable to all forces. It is applicable to only addition and subtraction of forces is applicable to collinear forces. If forces are collinear, means if line of action of forces is 1, then only it is applicable, otherwise not. So that one it is shown here. So right now you may not be understood. Inclined forces and collinear forces. Inclined forces we have to resolve itself. We cannot go further. But if the forces are collinear, we can go for simple algebraic addition or subtraction depending upon sign. After that, most important concept we have seen sign convention. So which force will be considered as positive and which force will be considered as negative? This we have seen.
Over and towards
Positive.
The force
Along positive x-axis and positive y-axis is positive.
very good. The force which is along or towards, which is along positive x-axis or positive y-axis is considered as positive. In other hand, if the force is towards positive x-axis, we can say it is towards right hand side. If the force is towards positive y-axis, we can say it is toward it is upward force. Means RHS towards RHS, towards LHS, towards right hand side, towards left hand side, upward and downward. So likewise, this also we have discussed, this most important thing. Okay, this one. It is most important. This also we have discussed. Okay, so this one is most important thing related to sign convention. Which force we have to consider positive, which force we have to consider negative. Okay, so its effect on the body, it will be considered as positive, negative. Likewise, if it is towards positive x-axis or positive y-axis, positive force. If it is towards negative y-axis, negative x-axis, negative force. In that way, we have discussed this sign convention. After that, resolution, just we have seen resolution, the method of splitting of force into its component without changing its effect is called resolution. The way of representing a force means here force is given F. So simple. Here force F is given. Okay, and that force F is making angle theta with whom?
Positive x-axis.
Positive
Very
x-axis.
good. It is making angle theta with positive x-axis. So here, by applying trigonometry, we have seen how to calculate its x component and y component. Its x component and y component. So here, trigonometry in next resolution of force. So whatever force was there, F. So whatever force was there, F. So what we have did, we have constructed. Here we have constructed what? Rectangle. Here we constructed the rectangle and it was something like this. Okay, in front of you. So we have applied number 1 sine theta in the rectangle ABCD. Then we have applied cos theta. By applying sine theta, we got the value of vertical component. We got the value of vertical component, which is f sine theta, and which we got then applying cos theta, cos function. Okay, we got value of horizontal component, means fh. Means if this vertical force is fv, so here it is also this will be fv. If it is horizontal component, then it will be again horizontal component in this way, parallel, because these are equal and parallel. That's why it is these are equal. So fh horizontal component, vertical component in this way. So here at the last I have told one conclusion. Whenever a particular force will make certain angle with the certain plane. Now here we should not keep in our mind. Here many students what they are doing. Whenever we are going to calculate, suppose horizontal component, we have to consider cos theta or cos function. Or other case, many confusion is there. Whenever we are calculating x component, for horizontal component it is also called as x component. For horizontal this component it is also called as x component. This for and this here I will say fh. for this FH also it is called as X component, and this FV vertical component is also called as Y component. So what students are remembering blindly in their mind, if we have to calculate X component or horizontal component, we have to use cos theta. So it is not correct, or it is not exactly correct, or it is, we cannot say blindly like this. Whenever we are going to calculate horizontal component or X component, we have to consider cos. So it is not like this, because what sentence yesterday I have told, with whom angle is given, with whom. So in this case, this theta is with whom it is given, with horizontal axis or vertical axis? Horizontal axis. That we have to ask ourselves whenever we are going to solve number of problems after. So we have to ask ourselves, with whom angle is given. Angle कोणा बरोबर दिलेला आहे. If angle is given with horizontal, then use cosine function while calculating its horizontal component or X component. That thing you have to remember, you should remember in your mind. So it is not blindly that whenever we are going to calculate horizontal component or X component, we have to use cos theta. It is not like this. Okay, so we will come to know that we will cross check also how it is possible. So in further problems. So meanwhile, just remember, with whom angle is given, with whom angle is given along that plane. If we are going to find its component, we have to use cosine function. You remember this thing. I will repeat while solving problem also. Same case here, it is given horizontal component, vertical component, whatever it was there, same is here. So force here means it is shown. It is shown how it is actually. So we will see how to find resultant. Means this force F is divided into two components. Which are the two components? So we have seen resolution. This force F is divided into two components. Which are they? One is horizontal component and another one is vertical component. Means this force is converted, we can say in general, one to many. So let us see its effect. Now whenever we want to calculate resultant, whenever we want to calculate resultant, this formula is there. We are going to use further. So that resultant, if R stands for resultant, then how it is calculated? Resultant square of X component plus square of Y component. It is very simple in this way. So likewise formula is there. We will come to across this formula. So if you will apply, which is for this given force, which is its X component, let us cross check here now by applying this formula. Which is X component or horizontal component of this force F?
Cos.
Effect.
That apex stands for horizontal component or X component, but what is its value?
F cos
theta.
F cos theta. So let us check. X component is F cos theta. So I will write here in short. So under root its square. So what will be its square? F square
cos square theta.
Cos square theta.
F square cos square theta. Okay, and what is its value of Y component? Here it is.
Sin theta. Yes.
F sin theta.
It will be
F square.
F square
sin square theta.
F square sin square
Theta.
So I will not go in detail. So what will happen here? What we can do? We can take common which term? F square.
Square.
So what will remain in the bracket?
Cos square theta plus sin square theta.
Cos square theta plus
Sin square theta.
sin square theta. So what is its value?
1.
Equal to 1. So what will be the final value?
F square.
Under root F square means means it will be F. Means F is equal to F, means whatever resultant. So what we are saying here, the effect should not change. Whether final force is F only, if at all we are resolving this force F into its component, its effect should not change. That force value should not change. It should remain F only. Means what it is done here. So don't worry. So it is not necessary to write Just I have told how it is. So whatever this force is divided into its component, its effect is not going to change. So that formula, etc., we will see further. So if irrespective of, though it is converted into its component, its effect is not going to change. Okay, so just it is shown resolution along x and y axis. So here also that F force, here F force angle is made with whom? X axis.
Fx.
So we have to use here cosine function likewise. Okay, it is just it is shown here, nothing else. Now here most important, description of force resolved in 4 quadrants. Description of force resolved in 4 quadrants. So yesterday we have discussed. Now this one is most important. This thing we have to learn today. So we should be able to check in which quadrant particular force will come. Okay, or so we have seen yesterday. I have drawn something like this. Maybe this x-axis. Okay, then here y-axis. Okay, in this way, suppose. So quadrant we are knowing very well. This one is first, where is second? This one is third, and this one is fourth. Am I correct?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so what we have seen in first quadrant. So in each quadrant there will be x and y component. In each quadrant there will be x and y component. Okay, that we have to see. Now here line of action of force is most important. In first quadrant, what will be the sign of x and y component in first quadrant?
Positive.
Positive.
Plus. Both will be positive. Okay, both will be positive. Both will be positive. What will be there in second quadrant?
Minus.
Plus.
Here minus plus.
Plus.
What will be there in third quadrant?
Minus.
Minus.
In fourth quadrant?
Minus.
Plus.
Plus minus. Plus minus. First we have to consider x component. Okay. So now I will draw one of the force. So line of, we have to see where that force or line of action is going. Suppose I will draw a force like this. Okay, in this way. Suppose force, I will give name as F. Force F in this way. So let us say F is equal to 10 kilonewton. Okay. So what do you feel? What will be the component, x component and y component of this force? Let us say this angle is 45. In which quadrant this force is?
First quadrant.
Or we have to ask ourselves where this force is going, towards positive y axis?
Third quadrant.
Third quadrant. In which quadrant this force is? Somebody has given
First quadrant.
first. Somebody has given answer. Third. Who has given third? It is correct. Who has given answer as a third quadrant?
Sir, it's me.
Okay, Seema, roll number 1. Okay, how do you feel? On which basis you are telling it is in third quadrant?
That arrow mark is going towards third quadrant, so I feel that it's
Very good. That is important. That arrow is nothing but line of action of force. So intentionally, I have drawn this force in first quadrant, but this force lies in third quadrant. Third quadrant. So are you remembering? Or most important, if at all I am going to increase this line of action of this force in this way, where it is going? That line of action of force, where it is going? Towards what?
Third quadrant.
third quadrant.
Third quadrant, or it is going towards, we can say, negative x-axis and negative
Y-axis.
Y-axis.
So what will be its x component and y component?
Negative.
What will be its x component and y component? Third quadrant. Now it is
Negative.
both will be negative. No, now there is no question to think. This force is coming into third quadrant. Though I have shown that force, so I would have shown here this force F. So you cannot say this force lies in first quadrant, because if at all you are going, finally where it is going finally, because just now we have seen in last lecture law of transmissibility of force. Law of transmissibility of force means along the line of action of force we can show this force anywhere, and finally where it is going, in third quadrant.
Third quadrant.
In third quadrant. Okay, so that's why this force, though it is shown in first quadrant, mainly it is lies in third quadrant. So just for your information, so likewise you have to think where it is going. Okay, so we will see some problems. So that's why I have told in this way. So we have to think where it is going. Okay, so let us see first quadrant, second quadrant, third and fourth, description of force in different quadrants, how it will be. So you can write in your notebook. So what will be its x component and what will be its y component? So by pen in your notebook you can write force in first quadrant. So how it will be? So Fy, and what will be sign of its x and y component, plus minus. Only that only we have to write. So one of the MCQ may be asked in your exam. Okay, so if force lies in suppose second quadrant, what will be its x and y component? In that way it may be asked. Okay, so just in first quadrant, if force lies in first quadrant, what will be its x component and y component?
Both are positive.
Both positive.
Both are positive. For multiple choice question it may be asked, so you can remember. So you can draw quickly this diagram: Fy, Fx, force F, F making angle theta with the positive x-axis, and here x component, y component. Similarly second quadrant. So here again angle is not shown. X component is given as Fx like this. Okay, so here angle is not mentioned. With whom angle should be made here? For which
X component.
X component. Why? Because with whom, for which component cos function is used?
For X component.
For X component. That's why this force has made angle theta with X component. Getting? Now there are two things to show. Component. Either we can show its sign or arrow direction. Means whatever this force is shown, here I will show this X component. I can show like this. Here I have made arrow. Fx is equal to, for second quadrant force, Fx is equal to F cos theta. F cos theta into bracket F cos theta. I have to show its direction. It is towards left hand side. Both are correct. Means in this way also it is possible to tell, or we can show it is like this also. What I have told here, what I have did, x component is equal to F cos theta, but into bracket what I have showed, in bracket
Direction.
direction I have shown, where it is going, towards left hand side or right hand side?
Left hand side.
Left hand side. Means like this also it is possible to tell. Both are same. Meaning of both is same. Means here you cannot say this force is this Fx component is not negative. You cannot say like this. Means either you can show sign or arrow, or I am saying not and. Either you can show sign or arrow. not both simultaneously. If you will show simultaneously, then meaning will be different. For example, so if, suppose if at all I will show, if at all I will show here arrow, if at all I will show here arrow, this meaning is different. It may show minus minus plus. Are you getting? It may we may consider. Somebody want to tell something?
No, sir.
Okay. So what I have told just now, either you have to show arrow or what?
Sign.
Either you have to show arrow or sign, not both simultaneously. If you show both simultaneously, that your force may get changed or it is having some different meaning. So in mathematics, simple mathematics, minus minus plus, this
Plus.
component will become plus. So sometimes if you refer some book, you may come to know that this fx is equal to f cos theta, add into bracket, this sign is shown. Okay, in this way. Or maybe fx is equal to minus f cos theta. Okay, only that much. Either you can show sign or arrow, but not both simultaneously. So take care of this. Okay, so, but what is this? It is always prefer to write sign. It is always prefer to write sign. Okay, because this it will show arrow, and suppose in further calculation we want to go for suppose addition, subtraction, etc. In that case, it may possible that you will forget that symbol where it is going actually, towards right, upward, downward, in that way. So that's why we will have always practice to show its sign. Okay, arrow is also correct, only you will show arrow into the bracket, it is also correct, but let us have a practice to show its sign. Okay, that's why here sign is shown. Fx is equal to minus f cos theta, fy is equal to plus f sin theta. So, and for this figure, this angle is theta. For this figure, this angle is theta. Getting? So this is for first quadrant, second quadrant. Very simple. Shall we go next?
Yes, sir.
Yes, sir. Yeah.
Third and fourth. You can note down this also. In third quadrant, y, this one is x. So for x component, f cos theta means definitely here angle will be theta. Okay, so fx is equal to minus f cos theta, fy is equal to minus f cos theta. Why it is so? Because
Both component are negative.
or other words, line of action of force is going towards, more technical or more specific language we can say, line of action of force is going towards which axis?
Third quarter.
No, axis, I must.
Y axis.
No, positive or negative?
Negative Y axis.
And
Negative X axis.
Negative x and negative y
X
axis.
axis.
negative x and negative y, that should be your specific answer. Okay, because in third quadrant both components are negative, because line of action of force is going towards negative x axis and negative y.
Negative y component.
Okay, next one is fourth quadrant. So again here this one is 4, here x, here y. For this one is theta. Okay, theta in this way. So what will happen in case of fourth quadrant? So you can draw with the pen in your notebook. X, y, force F. You can show theta, and how will be its x component, how will be its y component. Have you drawn? Very simple. There is nothing in this. So only we have to remember in first quadrant what is the sign of x component, y component. In second quadrant what is the sign of x component, y component. In third quadrant and in fourth quadrant, in this way. Or
Yes, sir.
Yes, sir.
same is shown here, nothing else. Whatever we have seen, same is shown. Forces in different quadrant. So in first quadrant same is nothing, it is just revision, not necessary to write. So plus x plus y you are observing here, plus x plus y. All the quadrants are shown directly, or we can say simultaneously. So whatever we have just seen, it was a single quadrants were shown, but here all the forces are shown, different forces are shown in different quadrants, and it is told that how are its x component and y component. Okay, likewise, so here also you can see it is something like this: x component, y component, x component and y component. Likewise, it is shown in this way. It is shown in this way. So in first quadrant, both are positive, x component as well as y component will be positive. In second quadrant, x negative, y positive. Third, both are negative. In third, both are negative, and in fourth, x component positive, y component is negative. Not necessary to write, just it is shown simultaneously how it is. Same is here also. Same is here. You can show how it is shown. F cos theta. So if you see here, f cos theta, f cos theta in this way. So we will see how it is shown. Are you observing on the screen? Just see, don't write here, not necessary to write. Already we one concept we have written. Are you observing screen? Different forces are shown.
Yes.
Yes, sir.
Yes,
Yes,
sir.
sir.
You can see, not necessary to write. Okay, further now that we have seen forces in different quadrant.
I have a question.
Yes, sir.
Why force is not going parallel to the y-axis or x-axis?
No, that we are going to see. Whatever your question is there, no. So here we are going to see forces along principal direction. Very good. So whatever question you have asked means why it is not going towards y-axis or towards x-axis. Asas na? Means parallel.
Yes.
You are saying, no?
Sir.
Yes, that we are going to see right now. So your question and our point of syllabus came exactly at one point. Okay, so whatever we have seen, it is inclined force. Either it is inclined to, or if it is in quadrant means it is inclined. Now we are going to see forces along principal direction. Forces along principal direction. What is principal? Which are the principal directions?
East, west, north.
East, west, north, south.
Don't read here, but directly if somebody will ask what are the principal directions, is it the way to tell east, west, north, south? You are, I think, reading out from the screen from here. How we are telling? In which sequence we are telling? Let it be. Whatever you have told, it is correct, but sequence
East, west, and south.
East, west, and north, south, or
South.
north. I feel so. If first we have to tell north, south, west, and east. So whatever, let it be. We will not waste in that time. So these are the principal directions. Principal means what? Principal. Principal. दोन शब्द असतात बघा, बऱ्याच जणांचं कन्फ्युजन असते. Which are these two words? So slowly I will write principal. PLE. And another one is principal म्हणतो आपण याला. What is the meaning? Whether these two words are different or same?
Different, sir.
Different.
What is the meaning of first?
मुख्याध्यापक.
Mukhyadhyapak.
Or we can say it may not. What is the meaning of first one?
Pracharya.
Are you sure?
No, sir. Second one
No,
is
sir.
Mukhyadhyap.
First one is मुख्याध्यापक, sir.
पहिल्याचं मुख्याध्यापक आणि दुसऱ्याचं
दुसऱ्याचं, sir.
These two words will come always in your life. So you should be remember what is the meaning of what. What is the meaning of first and what
The
is the
first
meaning?
one is a factor.
First one is
Fact.
fact.
Tatva.
Very good.
Tatva.
Okay, very good. It is fact or tattva. And second one is?
मुख्याध्यापक.
Second one is a head and मुख्याध्यापक.
So आपण मुख्याध्यापक म्हणायला नको, मुख्य म्हणू फक्त. हेड, इन शॉर्ट हेड. So मुख्याध्यापक हे what we can say, what we can say, first one is principal. We have seen. कुठलं पहिलं का दुसरं?
पहिलं.
परत कन्फ्युजन चालू झालं बघ.
दुसरे
नाही सर दुसरं.
Second one is more important, or we can say मुख्य, फक्त मुख्याध्यापक वगैरे. It is further. It is just a post in college, or we can say high school, etc. That meaning of principal is not always headmaster, but in your day-to-day life, important. We can say important, or what we can say, important, or we can say in Marathi मुख्य, प्रमुख म्हणूया आपण, प्रमुख थोडक्यात. That is principal. And what is principal म्हणायला? Paul, principal. Second one, and first one is principle. That we have seen, principle of law of transmissibility of force. Principle, तत्व. एक जणांनी सांगितलं कोणीतरी, it is good. Principle, that is meaning. आणि principal म्हणजे मुख्य, head. Likewise, not always the meaning is मुख्याध्यापक, so it is not like that. So what we are going to see here, forces along the principal directions or principal directions. मुख्य direction ला जर force असेल, means if it is towards north, towards east, towards west, or towards east, so how will be its component? How will be its component? That we are going to see here. म्हणजे एखादा force हा north कडे जातोय, north, it is going towards north. Okay, so what will be its x component and what will be its y component? Likewise, means here somebody has given just asked one question. If the force is parallel to x axis or force is parallel to y axis, so somebody just now has given this. If force is parallel to x axis, means this force is parallel, this force is parallel to, suppose x axis, force F, force F is parallel to, then what will be the effect due to that force? Now let me know. आता एक फोर्स कन्सिडर करूया आपण इथे. एक मी काय केलंय, क्वाड्रंट सिस्टीम काढलेली आहे. जस्ट नाव आय हॅव ड्रॉन वन ऑफ द क्वाड्रंट सिस्टीम वेअर आय हॅव ड्रॉन वन ऑफ द फोर्स एफ. हाऊ इज दॅट फोर्स? हा फोर्स कसा आहे? How is that force? Whether it is inclined to x axis, y axis, or is it along the x axis?
Parallel to x axis.
Parallel to x
X
axis.
axis.
Parallel to x axis. Now I will ask a question. If it is parallel to x axis, how much angle it has made with the x axis?
0.
0.
Zero. Very good. 0. Then our regular formula. जर x axis ची 0 केलेला असेल तर याचा f, what we can say it, what will be its x component? As per our formula,
F cos theta.
f cos theta. Very good. F cos theta. I will write here. F cos theta. Then in this case, I will write here.
F cos theta equal to F.
F cos theta. F cos theta. Okay, but what is the value of theta? Here just now we have seen, as it is parallel to
0.
x axis.
0.
0.
0. So cos 0 is how much?
1.
1.
1. So what will be the final answer?
F.
F.
Yep. On the other hand, as this force is parallel to x axis, what will be its y component? Yep.
F sin theta.
F sin theta. And what is the value of theta?
Equal to 0.
It will become 0.
0.
Okay, means here we will come to conclusion. One of the conclusion. What is that conclusion? If force is parallel to, suppose positive x-axis, or it is going towards positive x-axis, its y component is 0. असं म्हणूया का आपण मग?
Yes, sir.
Yes, sir.
Absolutely, we can say like this. If force is parallel to x-axis, its y component is 0. whether this case may be happen for the force which is parallel to y-axis. What will happen? Suppose particular force P, I will show. Force P is parallel to y-axis. So what will be your conclusion? Like this.
F cos theta is 0.
F cos theta?
0.
No, you can tell in terms of x component and y component.
X component 0.
X component will be 0.
X component 0.
X component will be 0. And what will be its y component?
P.
F.
No, I have taken notation here P for that force.
P.
It will be P in that way. So here what we can say in short, if the force is parallel to x-axis, its y component is 0. Okay, and if force is parallel to y-axis, its x component is 0. It is as simple as this, very simple. So likewise, so this one is also we can remember for multiple choice questions. Multiple choice in exam it may be asked the force F. So to confuse you, some values will be given. Force F having a value of 50 kilonewton is parallel to positive x-axis. Calculate its y component. So not necessary to calculate, directly you can tell as the force is parallel to x-axis, its y component is 0. Likewise, questions are asked, so we should be very carefully, we have to think what it is given. Or it may be asked something like this, a particular force of 40 kilonewton is parallel to 40 kilonewton is parallel to y-axis, or it is parallel to positive y-axis. What is its y component? Hi Ilma, एक force आहे.
40 kilonewton.
There is a force, one force 40 kilonewton is parallel to positive y-axis. What will be the value of its y component? Kitil? This force itself
40 kilonewton.
very good. This
40 kilonewton.
it will come 40 kilonewton because this force itself is nothing but 40 kilonewton. Okay, and what will be the value of its x component?
0.
It will come 0. It will come 0. Likewise, so same is here. Same is here. Due means towards. What is the meaning of due? Due.
Towards.
So just now I have told. If somebody what is the meaning of this?
Towards.
Towards. मराठीत काय म्हणायचं towards ला? Do we have to call? Towards. Chakade. Very good. Towards east. If the force is towards its east, suppose east. Now this directions you are knowing: north, south, west, east. If the force is towards east, means along which direction this force is going? Positive x, positive y, negative x, negative y. Where it is?
Positive X.
Positive x.
Okay, it will be going towards positive x-axis. Correct? Correct?
Yes, sir.
Yes, sir.
Yes, sir.
Now, if the force is going towards west, along which direction?
Negative X.
Negative
x-axis.
Negative x.
Yes, sir.
Okay. Negative x. If the
X.
force is going towards north,
Positive Y axis.
Positive
y-axis.
positive y-axis. Positive y. And if the force is going towards south,
Negative y axis.
Negative
Negative Y axis.
negative
y-axis.
negative y-axis. If the force is going towards south, then it is going towards now a question may ask. So here I have told if the particular force direction of force is giving a particular force of suppose 20 kilonewton is going towards north or due north. A force of 20 kilonewton is due north. What will be its x component?
0.
0.
Due north means where?
Towards north.
Positive x,
Towards
positive y.
positive
Positive y-axis.
Positive y-axis.
Positive y-axis. In that way, you have to remember. Suppose I will say a force of 10 kilonewton is going due south. What will be its
Negative y-axis.
negative
Negative
y?
y-axis.
Negative y-axis.
10 kilonewton force is going due south. What will be its value of y component?
10 kilonewton.
10 kilonewton.
Kilonewton.
10
Minus 10 kilonewton.
minus 10. That I was expecting. Minus 10. Due south means negative x-axis. No, so sign is important. It is going towards negative y-axis. So either you have to show minus 10 kilonewton or 10 kilonewton into bracket LH downward. Means in this way. What I have asked questions, many of you might have not just. So here I will show. So what I have shown, a 10 kilonewton force. 10 kilonewton force is going toward due south. Going due south towards management. Towards means due. Towards आणि due एकदम नाही वापरायचं. A 10 kilonewton force is due south. What will be its y component? काय असेल मग याचा y component? Due south आहे.
Minus 10
Minus 10
Minus 10.
kilonewton.
So you have to show what? Minus 10 kilonewton or किंवा हे दुसऱ्या भाषेत कसं सांगू शकतो? In other way, how we can write this? आता काय
10
करायचं?
Downward arrow.
Towards
Downward
bracket
downward.
arrow.
In this way, we can show downward arrow into the. We can show downward arrow into the bracket, so that we can say this is going in downward direction or minus 10 kilonewton. So it may possible to ask any question, any one of the question. So somebody just asked if the force is parallel to something or it is along the principal direction. So you should be identify. So you can note down this also. Forces along the principal direction: due east, due west, due north, due south. What is meaning of due?
Towards.
If it is going suppose towards east, so directions I have told. Towards east, positive x, west negative x, north positive y, south negative y, and accordingly you have to tell. So just now for this I have told, if force is going towards positive x-axis, its y component is 0. Likewise, direction is also most important. Direction is also most important. Okay, any problem? Very simple. It is very simple. For multiple choice question, it is important. For multiple choice question, so at that time you should not be under confusion. The force is going due north, means you should not be under confusion. What is this? If it is going towards north, so for that at least you should know principal directions. What are the principal directions? Are north, south, west, east. These are the direction. Okay, have you noted down? Have you noted down?
Yes, sir.
Yes, sir.
Shall we go next?
Yes.
Yes, sir.
Yes, sir.
Numericals on resolution of force. So let us see what is that. Next one is magnitude and direction of force to be resolved is given. So once we are going now, hereafter we are going to start the numericals on resolution of force. So in that case, what will be given? तर आपल्याला दिलेलं काय असणार आहे? Magnitude will be given, magnitude of the force will be given, and direction. Unless and unless direction is not given, जर आपल्याला डायरेक्शनच माहित नसेल फोर्सची, we cannot identify its sign. So direction is most important. So direction will be given and magnitude in terms of Newton, kilonewton, whatever it may be. It may be given in Newton or it may be given in kilonewton. So magnitude will be given, direction will be given. So considering the direction of the force, find its inclination with the horizontal direction. So here, not necessary to find always with horizontal, you can find with vertical also. Then if we will find its inclination with horizontal, so what will be its horizontal component or x component?
F cos theta.
F cos theta. So it will be F cos theta. If at all we are going to find the inclination of this with the horizontal, then that component will be F cos theta. And what will be F is the horizontal. So here also mentioned horizontal, but it is vertical. This one is wrong again. And the F sin theta will be vertical component. So here while solving the problem, what it is told, use proper sign convention to calculate the values. Proper sign convention means which convention we have to use here? Which convention? If force is
Sign.
going, no, sign convention, okay, but which?
Both positive.
No, not here. In general, I must.
Along positive x-axis, then positive.
And if it is negative x-axis, along negative x-axis,
Then it is negative.
in that way. So if it is towards, we can say positive y, we have to take it as a positive component. If it is negative y, we have to take. So what it is told in this, what it is told, magnitude and direction of force will be given in resolution of force. So try to calculate its inclination, not necessary with horizontal. If you are able to find its inclination with vertical, okay, you can find the inclination with vertical also. And accordingly, what the way I have told, ज्याच्याशी angle दिलेला आहे त्याचा cosine घ्यायचा. That's why. Likewise, you can calculate. So in general, it is here told that you have to calculate with horizontal, but not necessary always. प्रत्येक वेळी काय horizontal शीच component काढा. It is not like that. You can find with vertical also in that way. Okay. ओंकार माने आहेत का? ओंकार
सर वेटिंग मध्ये नाही. हॅलो सर. हॅलो.
ओंकार माने
वेटिंग मध्ये नाही.
Okay, so magnitude and force will be given. So this one will be our first problem. So now actual our subject is started, I will say. Actual our subject is started. Am I audible? Just check.
Yes, sir.
Yes, sir.
First example. So who will read this example? Now our actual subject, now hereafter you should be with calculator. Without calculator, now EM lectures are not possible. So who will read this problem? Loudly.
Determine the components of a force P is equal to 40 kilonewton along the x and y as shown in figure.
As shown in following figure. Very good. Determine the components of force P. It is shown in the following figure. So for this force, what is given? Just now we have discussed. What is given?
Direction and magnitude.
Yes, direction and magnitude is given. Okay. So what is its magnitude?
40 kilonewton.
40 kilonewton.
40 kilonewton. And whether direction is given?
Along x and y axis in third quadrant.
Along positive x and y axis.
Along positive. Okay, given. So first I will write. So write down the statement. Only simple problem we will see today. This one is 40. Force P is given 40 kilonewton. Now, for this force, shall I ask one question? In which quadrant this force lies?
Third quadrant.
Third quadrant. Why?
Its direction towards third quadrant.
Or its line of action of force is going towards
Third quadrant.
Third quadrant.
Third quadrant. So what will be its x component? Sine of x component and sine of y component.
Minus.
Both will be
Both
minus.
are
Both are minus.
both are minus.
Yes, both will be minus. So how with whom inclination is given for this force? कुणाची inclination दिलंय?
X component
Along x-axis.
along X.
Inclination is given with x-axis. Simple, we can say inclination is given with x-axis. So suppose x component, only we have to calculate component x and y. That's all. So what will be its x component? So I will say x
20 root 3. Minus 20 root 3.
No. X component px is equal to, what is formula?
P cos theta.
Minus 30.
Cos theta.
P cos theta.
P cos theta. Okay. What is the value of P? We are having 40.
40 kilometer.
40 kilometer.
And what is the value of this? Cos. Now you have to use calculator. Cos. How much we are going to take?
30.
30.
30. How much it is? How much it is?
Sir, negative sign.
That I will give next step. And py first. So cos, whenever you are going to put this sine and cos into in your calculator, just check whether it is in radian or degree. It should be in degree. It should be in degree. So that also you have to confirm. What is the value? So if you are not with calculator, please calculate. Tomorrow I am going to ask the same values.
20 root 3, sir.
Don't tell in terms of root 3. That also you have to calculate.
34.64.
How much? 50?
34.64.
34 point
64.
64. So in bracket, which type of arrow I have to show? LHS? Here. What is this value first?
20.
20.
20.
Okay, so this will be the value. Meanwhile, write your numbers in chat box first, so that we will stop for today. Write the numbers. If not, tomorrow we will solve this. You should be with the calculator from tomorrow. Problems are started now. So without calculator, you cannot attend the lecture. Shall we stop?
Yes, sir.
Karena yang jelas juga yang